All right, so we are starting our second unit, which is, it's actually review, and we're doing B. A was differentiation, so unit B is going to be integration. All right, so now we've reviewed all of our derivatives and hopefully remember all of our derivative rules and applications of derivatives. So now we're going to talk about integration, and then we'll do the applications of integration. But first, our beginning integration, target number 1 for integration, we want to talk about, do we remember what an indefinite integral is? An indefinite integral. Do you remember how to find antiderivatives? And can we find a particular solution? Those are things we want to know. Do we remember what integrals are to begin with? What is integration and finding antiderivatives? And then can we find a particular solution to an indefinite integral? All right. So first of all, going backwards, we need to make sure we understand if we have the derivative, if we have y equals, say we have y equals 3x squared plus 7x plus 5. Our derivative would be 6x plus 7. So now what we learned to do when we integrated was we do the integral of 6x plus 7, and you got your bookend dx on the end, and we want to do the antiderivative of that. So remember, when you're going forward, you multiply with your power rule and drop a degree. Okay? So here we're going to do the reversed. We're going to add a degree and then divide by the new one. So then we're going to add a degree and divide by the new one. And then we have to put a plus c. So remember, we always put that plus c on the end because we don't know what that constant was originally. So we end up with 3x squared plus 7x plus c. So the only difference is I've got this same expression back. We just don't know what the c was unless we're given some type of condition. All right, you have to be given an initial condition to be able to find the particular solution. So if I wanted this is just my general solution, 3x squared plus 7x plus c, that's my indefinite integral. That means I have an indefinite number of answers because the plus c means we can have an infinite number of solutions here on the end for what our constant is. All right, so if I want the particular solution where c has to be 5, I have to be given some information. For instance, I would have to be given something like this function has to contain the 0.05. All right. If this function contained the 0.05, then that would make C 5. So you have to be given some condition in order to find the particular solution to find C. So hopefully you remember about integrals and so forth. You got to remember your trig ones. Remember the integral of secant squared, whose derivative is secant squared. So just ponder that for a minute. Whose derivative is secant squared? So that would be tangent and then plus c. So, you know, you've got to go back to all of these things here. So what is the antiderivative of sine? So what's the integral of sine? So whose derivative is sine? Well, I know somebody's derivative is negative sine. So that means this must be negative cosine plus c, because the derivative of cosine is negative sine, so that's going to make this be positive. So you just got to go back and remember your integration rules, all right, and how to do integration. And what if you have something like we're trying to do the integral of x, and on the inside we have, say we have x squared plus 1 to the 3rd power. Do we remember how to integrate those more complicated problems? All right, that's where you do your u substitution. So you let u be the stuff in the parentheses, and then you do your du. So du would be 2x dx, and then we solve for dx by dividing by 2x. So that'd be du divided by 2x, and then we come over here and we trade out. We let that be u cubed, and in place of dx, we put du over 2x, and now the x's cancel. And then I told you to put things in order so that it makes more sense. You do your coefficient first, then your function, then your bookend du, and now you do your antiderivative. So we keep our coefficient. The antiderivative of u to the third is add a degree, so u to the fourth, and then divide by 4 plus c. So that means my final answer is 1/8 u to the fourth plus c, and then I put u back in. All right, so my u was x squared plus 1 to the fourth power plus c. So I hope this is coming back to you a little bit. Doing u substitution. Remember, we reverse power rule, and then for everything else, you do u substitution to put it as a power rule, and then plug it back in. So going backwards integrating is so much easier than learning all of the derivative rules, because there's really only two things you got to remember. You got to remember how to reverse power rule, and then everything else, pick a u substitution so it simplifies it down to a power rule, right? So then you reverse your power rule, and then you plug your substitution back in. That's what everything is when you integrate. All right, so hopefully you remember doing integration, and hopefully you remember how to find antiderivatives by reversing the power rule or doing u substitution, and finding a particular solution. Again, in order to find the particular solution, that means I've got to solve for c, and so in order to do that, I have to be given some initial condition that is going to help me find what c is. All right, so for instance, in this problem, if I was told that y equals all this, then I would get this answer, that y equals 1/8 x squared plus 1 to the fourth power plus c. So now if they wanted me to find a particular solution with a c value, they would have to give me some initial condition, such as something like when x is 1, your answer is going to be, I don't know, 14. I don't know. I don't even know what the answer is going to be for 14, but anyway, we'll figure it out. All right, so if x is 1, our answer is going to be 14. So I'm going to go over here and say, okay, when x is 1, so that would be 1 squared plus 1 to the fourth plus c. I need to get the answer 14. So what c value is going to make that happen? So let's see. 1 squared plus 1 is 2. 2 to the fourth power is 16. 16 divided by 8 is 2. So 2 plus c equals 14. So that means c, subtract 2, got to be 12. So that means in order to contain this point right here, the equation, the particular solution is going to be 1/8 x squared plus 1 to the fourth power, and then my constant is going to be a plus 12. So this is my particular solution. That's my particular solution when I have the initial condition that when x is 1, y has to be 14. So this one here is your general solution, because this means we have an infinite number of answers, because the constant can be a million billion things. So there's an infinite number of solutions to your general solution for the solving of an antiderivative. Let's do an antiderivative. All right, so then if I want a particular solution for this antiderivative, I have to be told some type of initial condition that I can plug it into my general solution to solve for what c is, so I can get a particular solution or one specific curve that goes through the point 114. So I hope this jogs your memory. So you've got plenty of things to work on. Within this lesson, there's an indefinite integral circuit. So, you know, that's easy because it self-checks. So do some indefinite integration and check yourself by following the circuit. And then there's a particular solution practice where you've got to find the particular solutions given the initial conditions. And then you've got your target practice where you've got a little bit of both. So in this lesson, hopefully you go back and review how to do antiderivatives integrate. We're not doing definite yet with numbers on the integral sign yet. So save that for another lesson. So go ahead and do your practice.